Can you please give me two unknown numbers? Unknown, do not select anything. So two unknown numbers whose sum is 16. How would you write that? Common sense, thank you very much. So that is done. Find the pair whose product is maximum. Okay, so I have to write the product. I cannot find the maximum of a function if I don't have the function. I have to have the function to find its maximum. Okay, so can anyone give us the product of these two numbers? How do we write the product of x and y? Very good. So this is all the information I have so far. But look at the second equation. This is the dependent variable. This is one independent variable, and this is another independent variable. I can't have three variables, the function and two more. So somehow I would like to get rid of this. If I make that disappear, in terms of x, of course, then I have a function that has only one variable in it. So from here, what will you do? Right, we will solve for y, so this is negative x plus 16. So y or negative x plus 16 is the same thing. So, but now I can say that this function that I'm going to write is a function of one variable only. And that is the variable, x. Is this clear? Okay, then I will distribute. And now ask myself several questions. I know I sound like a broken record. They are the same questions. What type of function is this? Quadratic. Does it have a max or a min? It has a max because the leading coefficient is negative. Now the final question, how do I determine the maximum? Because I'm asked to find those numbers that give a maximum product. So how do I find the maximum of this function? The vertex, indeed. The answer is always the vertex. How do I find the x-coordinate of the vertex? This is our function. Good. Negative is from the formula, 16. 2 times negative 1. So then what is the first number for sure? That will give a maximum 8. X is 8. Do not confuse this y value of the function with this y value, which is the other number in the problem. So this and this are not the same. You can say, but this is the y value. Yes, it's the y value when I plug in 8 in p. So when I find p of 8, yes, I agree. But this is a totally different y value. When I replace x by 8, what do I get for this particular y value? Good. So now remember, this product is x times y. If you have x and you have y, it's the same with p of 8. It must be the same because this was determined by multiplying x and y. If x is 8 and y is 8, this must be 64. If you want to convince yourselves, that's fine. Let's find p of 8. Negative 8 squared, which I do not have parentheses here. I'm squaring 8 and then multiply the answer by negative 1 plus 16 times 8. And this is negative, careful, it's 8 squared times negative 1, which is negative 64, and plus 16 times 8. And the answer must be 64. And the answer is 64. There are two different ways of determining this y value. Okay, so now we have to write the final answer. Max product of two numbers that add up to 16 is 64. The numbers are x equals 8, and y equals 8. This is the full and correct answer. The maximum product of two numbers whose sum is 16 is 64, and respectively the numbers are 6 and 6. You understand that you cannot find another pair of numbers whose product is larger than this, because this is the maximum. So if you deviate from, let's say, x equals 8 to x equals 9, this will be your maximum, not this. If you go the other way to 7, this will be your maximum, not this. There is only one maximum. Any questions from me, please? Kira, go ahead. Any questions?
Oh, no, my nose is
Say it again.
my nose is stuck.
Okay. I feel the same. I drank my bottled water. Almost. Any questions? Any questions? Okay. Let's continue with 3.2. This is new. It should be new to you. So it will take forever. For me, I'm exaggerating, of course. I just want to warn you. It will take a long time for me to explain the topics that we have not seen before we put everything together and be able to graph like we did. So first we analyze the quadratic function, what, where, intercepts, max, min, axis of symmetry, to apply it in more problems. The same thing we're going to do with what's next, but these are more sophisticated functions. So they need more details and more stuff, okay? So bear with me. The first problem will take 10 minutes or more, the second one 5, and the third one 1. So I'm exaggerating it at both ends, of course. So, but I just wanted to give it a heads up. I need a lot of explanation here before we put everything together. 3.2, polynomial functions. And you can say, wait a minute. You just talked about linear and quadratic. What are those? And I would say they're also polynomial. But those are the simplest possible forms of polynomial. So linear, done. Quadratic, done a minute ago. But what we're really talking about when we think of polynomial functions, although these two are also polynomial, we not just linear and quadratic, but they come from polynomial functions. When we talk about polynomial functions, we normally talk about degree 3, 4, 5, 6, 7, etc. This is what we refer, when we talk about polynomials, this is what we refer to. Bless you. Degrees 3 and higher. Okay. These functions, before we realize what's happening here, before we are able to graph them, we need several concepts that we have not talked about before. Okay. I'm going to create a table. I'm not telling you what I'm talking about just yet. In a minute, we're going to fill this in. I'm going to put on the left-hand side odd degree. On the right-hand side, even degree. I'm not talking about odd functions and even functions. I'm not talking about symmetric functions. No, I'm only saying odd degree, meaning degree 3, degree 5, degree 7, 9, and so on and so forth. When I talk about even degree, I'm referring to degree 4, degree 6, degree 8, and so on and so forth. So I have a title to put in here. I don't want to put it just yet. In a minute. Okay, so I want you to give me the simplest possible odd degree polynomial function that we know absolutely everything about. Say it again.
F of x equals x plus 2.
That's linear. Excellent. linear. The linear function is the simplest possible odd degree. I knew something was wrong here, and I said, what am I writing there? So correct. Nobody said anything. Please don't let me get away with. And then when I scan it and I look at this, what? What did I write? Sorry about that. Okay, so linear has two options, right? This option and this option. What is the leading coefficient here? And what is the leading coefficient here? What the type of linear? You don't have to give me a number. But what is the leading coefficient here? Definitely. Yes, of course. This must be a positive number. What about here? Negative. Very good. Okay, so this linear function has a positive leading coefficient or negative? Positive. So it's coming from what kind of values? Negative infinity to, right. So it's coming from a negative infinity and going to positive infinity. Okay, let's look at the other. This is a linear function with a negative leading coefficient. Where is it coming from? And going to? Okay, very good. So this is the other way around. All odd degree polynomial functions will have the same behavior. It's called end behavior. So if I say degree 5 and positive leading coefficient, what would you say? This end behavior or this end behavior? Degree 5 and positive leading coefficient. Right? We agree? It's coming from negative infinity going to positive infinity. What if I say degree 7 and negative leading coefficient? There are 3 pages on this topic in their book. There's no need for something like that. So, is this clear? Can anyone give us the, of course, this is the same title, and behavior. So can anyone give us the simplest possible even degree polynomial function? Even degree. Quadratic, right? Either this or this. What is the leading coefficient here? We just finished that. And what is the leading coefficient here? Yes? Okay, so here is a quadratic function with a positive leading coefficient. Where is it coming from and where is it going to? It's coming from and going back to. Good. What about the other one with the negative leading coefficient? It's coming from and going back to. Okay. What does this mean? It means that all even degree functions will follow the same behavior. All odd degree polynomial functions will follow the same behavior. If the leading coefficient here is positive, they will come, all functions, all even degree functions will come from positive infinity, go back to positive infinity. If they have a negative leading coefficient, sorry. They come from negative infinity and go back to negative infinity. So this is a topic that is part of polynomial functions, more than here because we already knew the answer, but we don't really know the answer for the other ones, but now we do. So this is a major topic called end behavior. Okay, the next topic that we have never seen before, never talked about, is called multiplicities of X-intercepts. We have never talked about this before. Multiplicities of X-intercepts. Okay, let me give you a couple of examples. Let's say I have f of x equals x minus 1 to the fourth, and x plus 4 to the third power. And I'm asking you, what is the degree of this polynomial? Well, let's take it slowly. What is the degree of this? What is the degree of this? So 3 plus 4 is, and times 1, or plus 1, degree 8. Very good. So this polynomial is degree 8, which is an even degree, and definitely the leading coefficient is positive. Which of these two options will it have for the end behavior? You can say, wait a minute, you're talking about multiplicity. It's true. I just want to connect the topics. So we found a degree 8 polynomial. Will it have this situation or this situation for the end behavior? Is that clear? Because it has positive leading coefficient, it's a even degree, and it will come from positive infinity, go to positive infinity. So it will do this, something else in the middle, I don't know yet what it's doing in the middle, not the same with the quadratic, of course not, something else, but definitely coming from this and going back where it came from, because it's even degree. Okay, forget about that for a moment. So then, how many solutions will f of x equals 0 have, which is x-intercepts? How many x-intercepts will I find? Mandatory, always, forever. What will be the number? 8. So when I set this equal to 0, x minus 1 to the fourth, x plus 4 to the third equals 0, you will give me 8 solutions. And I'm ready when you are. And yes, I'm still talking about multiplicities, but I didn't get there to explain anything yet. So the first solution, yes, x equals 0. How many times, that's the multiplicity, how many times does x equals 0 appear as a solution? 1. Next solution, please. X equals 1, how many times? X equals 1, multiplicity, 4. Last one, x equals negative 4, multiplicity, 3. What was the degree again? How much is 3 plus 4? How much is plus 1? Okay, and now you can say, okay, you're making a big deal out of this one, so what does this really mean? Okay, I counted how many times a solution appears as an x-intercept, but what's the point of this? Here it is, and here's the explanation. I'm going to graph several possibilities. I'm going to do it the other way now. I hope you agree that the first 3 graphs cross the x-axis. Would you agree? And the second, the last 2, the third and the fourth, are turning on the x-axis. They're touching the x-axis, but they're not crossing it in the sense that they're coming from negative to positive or from positive to negative. They're touching, but turning at the same point. Is that clear? Okay. Every time a function, a polynomial function, crosses, has an odd multiplicity. Nothing to do with the degree, nothing to do with symmetry, nothing. No connection whatsoever. So here is a multiplicity 1. Normal cross. Here it's a multiplicity 3. It takes its time. There is only one cross. but it takes its time. It's not in a rush to cross. It takes its time. Here it takes even longer to cross. It moves away from the x-axis very slowly. It moves away from the x-axis very slowly, much slower than this. What do you think the multiplicity is here of that particular number, of that solution? Indeed. Fast, multiplicity 1. Slow, multiplicity 3. Slower, multiplicity 5. Even slower, multiplicity 7, as long as it crosses. These two are turning. So again, this is odd multiplicity. This will be even multiplicity. And we know this one. What is the multiplicity of this solution? We graphed it many times. 2. What is the multiplicity of this solution? It takes time.
4.
Yes. And so on and so forth. If the function turns, it's an even multiplicity on the x-axis. If it turns on the x-axis, it's an even multiplicity. If it crosses the x-axis, it's an odd multiplicity. Okay. That's really all I needed. And now we can start graphing those functions. We know nothing about graphing them yet. But here's a list of items to look at or determine when we graph a polynomial function. Graphing a poly function. Not linear, not quadratic. We're talking about degree 3, 4, 5, etc., etc., etc. Okay? Number 1, and they don't necessarily have to be in this order. Domain. Number 2, X-intercepts. And their, what is the word I'm missing? Their three, Y-intercept. 4, of course, and behavior. 5, degree. 6, max possible number of turns. By a turn, we mean a max or a min. The rule is always degree minus 1. So coming back here for a moment, the degree was 8. What is the maximum possible number of turns for this function? Or 7, exactly. 7. Max, min with, we cannot do this by hand, TI-84. It's a long list. An 8 range. After we graph, of course. Okay. As I mentioned, it took me 20 minutes to explain all this, to talk about multiplicities, to talk about the list of items that we need to graph a polynomial function. They will be listed for you in all problems. I will list these requirements or these questions. And also talk about the end behavior. Now, when we look at the first problem, you'll see it's not going to be that long. What type of problem would you like? Would you like to look at the polynomial degree odd or even? Let me show you where they are, and you can choose. Because we only have 5 minutes left, and I'd like to complete a problem, any problem you want, please choose from the ones that are already factored. And next time, we're going to practice from the ones that are not factored. So just choose any problem from here that you like, so we can go through it.
61, please.
61. So negative 2x cubed, x minus 1 squared, x plus 5. So 61 is on page 378. F of x negative 2 x cubed x minus 1 squared. And yes, I think, yes, it was x plus 5, yes. Good. I highly recommend the following table in which we will summarize everything. And the table will help us graph the function very easily. Okay, so I'm going to show which item we start with, or I will cross it out. I would like us to identify the degree. So 3 plus 2 plus 1. Excellent. Maximum possible number of max min or turns. Very good. Possible 5, which means the function does not have to have 5 max min, but it cannot have more than 5. That's why it says maximum possible turns. So let's think about x cubed. What is the degree of x cubed? What is the maximum possible number of turns for x cubed? 2. Does it turn? Look at my hand. Does it have a max or a min? It doesn't turn. A turn means a turn, either a max or a turn, a min. X cubed is always increasing. It's never decreasing. That's why we studied increasing, decreasing intervals. But it can turn twice. But it doesn't turn at all. But it cannot turn more than twice. So careful with that. Good. So that is done as well. Now I would like to find the domain, please. What is the domain of any polynomial function forever, always? Negative infinity to infinity. Done. We need to identify the end behavior next. You said degree 6. There are 2 options. Perfect. There are 2 options for degree 6. One option or the second option. But it all depends on the leading coefficient. So is it this or is it this? Second one. Because the leading coefficient is negative, so then end behavior is negative infinity to negative infinity. Well done. Okay, now I want the x-intercepts and their multiplicities. So I have negative 2x cubed, x minus 1 squared, x plus 5 equals 0. And you have to come up with 6 solutions. Yes, x equals 0 how many times? 3 times. Very good. X equals 0 3 times. What is the multiplicity? Excellent. So this is done. This is done. Of course, that's a number.
X equals 1.
How many times?
2.
And?
X right there.
1.
1. 3 plus 2 plus 1, does it equal 6? To check, we have to make sure. 3 plus 2 plus 1, does it equal the degree?
Yes.
Perfect. So I put them in the correct order. Negative 5, 0, 0, 0, and 1, 0. Here's what happens next. At 0, there is a multiplicity 3. It will cross flat. That's my note to myself. At x equals 1, it has multiplicity 2. It must do what? Very good. And x equals negative 5 multiplicity 1, what will it do here? Cross. So, done. I want the y-intercept. How do I find the y-intercept? And you can say, it's already there. When you plug in 0, you get 0. I'm done. So that is done. The max min will be with T83, and the range, I have to see the graph. So the explanation took us 20 minutes, and just to find these, it took us 2 or maybe 3. Okay. So let's see what happens now. We're graphing. I know I have, oh, I'm sorry. I'm sorry. I can never finish.